Picture yourself standing in the biggest stadium you can imagine. Now stretch that space in your mind until it's larger than a city, then a country, then the entire planet. Even this monumental scale would be a mere speck compared to the boundless expanse of our solar system. It's so vast that light itself, traveling at an unimaginable speed, takes over 8 minutes just to reach Earth from the Sun, and years to touch the planets at the edges of this cosmic neighborhood. But here's the question that truly sparks wonder. Could humanity ever dream of crossing these staggering distances? This video will take you on an awe-inspiring journey through the unimaginable size of our solar system, from the blazing heart of the Sun to the icy frontiers of the mysterious Oort Cloud. Along the way, we'll explore groundbreaking futuristic technologies that might one day make interstellar travel a reality. Buckle up as we dive into a realm where science and imagination collide, and where the impossible might just become possible. Now turning to the structure of our solar system, let us begin at its very core, the Sun. This fiery giant is not only the centerpiece of our cosmic neighborhood, but also the source of light, heat, and energy that sustains life on our planet. Surrounding the Sun are 8 planets, each unique in its size, composition, and distance from their shared star. The inner planets Mercury, Venus, Earth, and Mars form what we call the terrestrial planets, characterized by their rocky surfaces and relatively close proximity to the Sun. Beyond these lies the Asteroid Belt, a sprawling region filled with countless rocky fragments left over from the early days of our solar system's formation. This belt acts almost like a dividing line, separating the inner planets from the outer giants. As we venture farther out, we encounter Jupiter and Saturn, 2 colossal gas giants that dominate this region with their immense size and striking features, like the awe-inspiring rings of Saturn. Travel further still, and we reach Uranus and Neptune, the ice giants, known for their chilling temperatures and unique atmospheres filled with mysterious elements like methane. But the solar system does not end there. Beyond the orbit of Neptune lies the Kuiper Belt, a vast expanse of icy bodies, including Pluto, which was reclassified as a dwarf planet. This region is a treasure trove of ancient relics from the early solar system, offering scientists a glimpse into its primordial past. And still farther out lies perhaps the most enigmatic frontier of all, the Oort Cloud. This hypothesized spherical shell of icy objects envelops the solar system, marking the limits of the Sun's gravitational pull. To give you an idea of scale, the distance from the Sun to the edge of the Oort Cloud could be as much as 100,000 times the distance from the Sun to Earth. It is here, in this remote and largely mysterious realm, that the solar system truly demonstrates its almost unfathomable size. Each of these zones, from the blazing Sun to the icy edges, plays a critical role in shaping the solar system as we know it, contributing to the incredible diversity and vastness of this cosmic expanse. With the next phase of the journey in sight, let us move deeper into the more familiar territory of the inner solar system and explore what makes it such an intriguing realm of human discovery. With the next phase of the journey in sight, let us delve into the inner solar system, a region that feels almost like home compared to the vast unknowns beyond. Here, from Mercury to the Asteroid Belt, the planets are relatively closer to one another, making this zone seem more accessible, at least by cosmic standards. Mercury, with its searing temperatures, and Venus, shrouded in thick clouds of sulfuric acid, remind us of the extremes our neighboring worlds can offer. And then we have Earth, uniquely teeming with life, accompanied by our moon, the only celestial body beyond Earth where humans have set foot. The Apollo missions of the past gave us our first tangible taste of extraterrestrial exploration, a monumental achievement that continues to inspire dreams of venturing even further. Mars, often called the Red Planet, stands out as the next great goal for human exploration. Its intriguing landscape of vast canyons, towering volcanoes, and polar ice caps has already been studied extensively through robotic missions like the Mars rovers. These tireless explorers have uncovered vital clues about the planet's past, including evidence suggesting it once had liquid water. Such discoveries ignite hope that Mars might one day support human habitation. Yet, even in this relatively nearby region of the inner solar system, astronauts would face immense challenges, surviving the long journey, dealing with the intense radiation from space, and creating sustainable life support systems on an entirely foreign world. Despite these hurdles, the inner solar system serves as a stepping stone. Each mission, whether to the Moon or Mars, pushes the boundaries of human ingenuity and prepares us for the longer, more daunting voyages ahead. It is here, in this familiar yet challenging territory, that humanity continues to take its first steps toward mastering space exploration. Moving forward, let us look beyond this relatively familiar realm and into the outer solar system, where the vast distances and colossal planets present an entirely new set of wonders and challenges. With the next phase of the journey in sight, let us venture into the outer solar system, a realm where the vastness of space truly begins to sink in. This is the domain of the gas giants and ice giants, starting with Jupiter, the largest planet in our solar system. Jupiter's immense size and powerful magnetic field make it a wonder to behold. Its swirling clouds of ammonia and water create mesmerizing patterns, and the Great Red Spot, a massive storm that has raged for centuries, stands as an iconic feature of this colossal world. And then there are its moons, a miniature solar system in themselves. Europa, with its icy crust and subsurface ocean, is particularly thrilling, sparking speculation about the possibility of life beneath its frozen surface. Beyond Jupiter lies Saturn, famous for its stunning rings made of ice and rock particles. These rings, though incredibly thin, stretch out over hundreds of thousands of kilometers, creating a spectacle that has captured human imagination for generations. Saturn's moon, Titan, with its dense atmosphere and lakes of liquid methane, presents an environment so different from anything we know, yet intriguing enough to warrant serious study about its potential to harbor exotic forms of life. The Cassini mission provided unprecedented insights into both Saturn and Titan, offering us some of the most breathtaking images of the outer solar system. Farther still, we encounter Uranus and Neptune, often referred to as the ice giants because their compositions include icy materials like water, ammonia, and methane. Uranus, with its peculiar sideways rotation, and Neptune, with its vivid blue color and supersonic winds, represent the cold and mysterious extremes of our solar system. These planets, while farther away and less explored, are no less fascinating. The Voyager missions, which gave us our first close-up glimpses of these distant worlds, remain a testament to human ingenuity. Even today, they continue to drift outward, carrying with them golden records time capsules of Earth meant to tell our story to any potential discoverers among the stars. The distances in the outer solar system are staggering, dwarfing the relatively cozy inner solar system. For example, the distance from Jupiter to Neptune is over 3 billion kilometers, a journey that light itself takes hours to cross. Traveling these vast expanses with current technology represents a monumental challenge. Spacecraft like Voyager 1 and 2, which rely on traditional propulsion methods and gravity assists, took years to reach these distant planets, and they had to sacrifice stopping for detailed study of any one world to achieve their monumental flybys. The sheer time it takes, combined with the harsh environment of deep space including dwindling solar power and intense cosmic radiation, pushes the limits of engineering and endurance. Through these challenges, the outer solar system offers unparalleled beauty and mysteries. It is a place of extremes where colossal planets and their diverse moons paint a picture of what lies beyond the familiar. Each mission that reaches these distant worlds teaches us more about the universe and pushes the boundaries of what seems possible. With our gaze now fixed on the farthest reaches of the solar system, let us extend our journey to the Kuiper Belt and the enigmatic frontier beyond it, where the true boundary of our cosmic neighborhood begins to come into view. With the next phase of the journey in sight, let us turn our focus to the Kuiper Belt, a distant and icy expanse that lies beyond Neptune. This vast region is home to countless small, frozen worlds, including the once labeled ninth planet, Pluto. The Kuiper Belt represents one of the most intriguing boundaries of our solar system, a place where our understanding of planetary formation and the early days of the solar system takes shape. Within this icy frontier, we find objects composed largely of frozen water, ammonia, and methane, remnants from the solar system's birth over 4.5 billion years ago. Pluto, one of the most well-known inhabitants of the Kuiper Belt, captivated the world during the New Horizons mission in 2015. This spacecraft, traveling for nearly a decade, provided the first ever close-up images of Pluto with its rugged mountains of solid ice and plains of frozen nitrogen. Beyond the remarkable landscapes of Pluto, New Horizons also revealed glimpses of Charon, Pluto's largest moon, which, with its own mysterious surface features, adds to the richness of this region. However, the mission did not stop there. Continuing its journey deeper into the Kuiper Belt, New Horizons flew past another small world called Arakoth, an icy object that offered insights into how planetary building blocks might have collided and merged in the early solar system. The Kuiper Belt is not just an endpoint of exploration, but a significant frontier that challenges our ability to comprehend distances in space. To put this into perspective, sunlight, the fastest thing in the universe, takes roughly 4 hours to reach Pluto from the Sun. Meanwhile, New Horizons, one of the fastest spacecraft ever launched, took an astounding 9.5 years to make this journey, even with the help of a gravity assist from Jupiter. Reaching the Kuiper Belt with current technology requires meticulous planning and an endurance to navigate vast, empty distances that strain even the most advanced engineering. Despite its icy isolation, the Kuiper Belt is a treasure trove of science. Each distant object explored in this region adds a piece to the puzzle of how our solar system was born and evolved. Yet, this boundary is far from the final one. Beyond the Kuiper Belt lies an enigmatic shell of icy objects known as the Oort Cloud. It is here, in this distant and theoretical realm, that the true edge of the Sun's gravitational influence may rest. As the Sun rises on the next chapter of our journey, let us venture toward this ultimate frontier, the Oort Cloud, and explore what lies at the extreme boundary of our cosmic neighborhood. As the Sun rises on the next chapter of our journey, we turn our gaze to the distant and mysterious Oort Cloud, the final frontier of the solar system. This theoretical shell of icy objects surrounds our solar system like an immense bubble, extending up to an unimaginable 100,000 times the distance between the Earth and the Sun. To put this vastness into perspective, if the Earth's orbit were the size of a small coin, the outer edge of the Oort Cloud would stretch beyond the size of a football stadium. It is here, at this incredible boundary, where the Sun's gravitational influence begins to fade into the vastness of interstellar space. The Oort Cloud has yet to be directly observed, its existence inferred from the behavior of long-period comets, those whose orbits can take thousands or even millions of years to complete. Scientists theorize that the Oort Cloud is a reservoir of icy bodies that were scattered outward during the early chaotic days of the solar system's formation. These frozen remnants, containing the same materials that built the planets, represent a time capsule from over 4.5 billion years ago. Reaching the Oort Cloud would be a challenge of staggering proportions. To date, even our most advanced spacecraft, such as Voyager 1, which has traveled farther than any human-made object, has not even come close to its inner edges. Voyager 1, currently over 12 billion miles from Earth, would take thousands of years to reach the Oort Cloud at its current pace. The sheer distance to this region means that crossing this ultimate brink requires technologies and timescales far beyond our current capabilities. Yet, the significance of the Oort Cloud cannot be understated. It not only defines the boundary of the Sun's gravitational domain, but also symbolizes the outermost edge of what we call home. This distant region challenges our understanding of the solar system's architecture and sets the stage for the profound question, what lies beyond? As we contemplate the Oort Cloud, its vastness reminds us of both the limits of our reach and the boundless potential for discovery that lies ahead. With this, we prepare to ask the ultimate question: could humanity one day traverse these unimaginable distances and truly cross the solar system? With the next phase of the journey in sight, we confront the awe-inspiring question: what does it truly mean to cross the solar system? To some, it might mean reaching its outermost boundary, the Oort Cloud, while to others it could signify venturing even beyond, to interstellar space and the next star systems. However, the enormity of this challenge is almost beyond comprehension. Imagine traveling from one end of your country to the other by car. Now, scale that up by thinking about flying across the planet in a jet. Crossing the solar system, by contrast, would be like trying to walk across the entire length of the Earth hundreds or even thousands of times. The distances are so vast they defy our everyday understanding. To accomplish such a feat would require an entirely new era of human innovation. The technologies we have today, rockets powered by chemical fuel, and even the ion propulsion engines used on some space probes, are like bicycles when what we need are spacecraft equivalent to supersonic jets. Current spacecraft, like the Voyager probes, demonstrate the limit of what we can achieve now. Extraordinary achievements, yes, but still painstakingly slow by the standards required to traverse the entire solar system. These missions have taken decades to journey just a fraction of the way. At their current speeds, reaching the Oort Cloud or beyond would take tens of thousands of years. This stark reality underlines how far our technology must evolve to make such a journey feasible. But technology is only one side of the story. The concept of crossing the solar system also raises questions about time itself. For journeys spanning thousands or millions of years, we must consider whether humans could ever even witness the results. Would we send robotic explorers as proxies, or could we imagine human missions where generations would live and die along the way? The scale of time involved pushes the boundaries of what we can presently grasp, both scientifically and philosophically. Still, pondering this vastness ignites the imagination and reminds us of our unique ability to dream beyond the limits of our current capabilities. So, with a mix of wonder and determination, humanity faces perhaps its greatest challenge yet: discovering a way to bridge the inconceivable distances of our solar system and beyond. As the next challenge unfolds, we dive into the monumental hurdles standing in the way of crossing our solar system. First, let us consider the limits of propulsion technology. The rockets and engines we depend on today are simply not designed for journeys spanning billions of kilometers. Chemical rockets, while powerful for launching into orbit, run out of fuel too quickly for extended missions, and even ion propulsion systems, though more efficient, are far too slow to cover such immense distances within a human lifetime. To even dream of traversing the solar system, we would need entirely new propulsion methods capable of achieving speeds that are almost unimaginable by today's standards. Perhaps nuclear propulsion or even speculative concepts like antimatter engines could one day be the key, but each of these technologies presents massive engineering challenges that remain unsolved. Next, there is the overwhelming issue of time and distance. Even at the blistering speeds of the Voyager probes, which travel at tens of thousands of kilometers per hour, reaching the outer boundaries of the solar system would take tens of thousands of years. For perspective, human civilization as we know it has not even existed for that long. This stark reality forces us to rethink how we would even approach such a mission. Could we create spacecraft that travel significantly faster, or would we need to find entirely new ways of navigating these cosmic distances? the timeframes involved push the boundaries of our imaginations, making it clear just how far from reality this ambition currently is. Then consider the dangers of space itself. Radiation exposure from the sun and cosmic rays would be a constant threat to both humans and delicate electronics on board. While Earth's magnetic field and atmosphere protect us from these hazards, a spacecraft traveling through interplanetary or interstellar space would have no such shield. Solutions like enhanced radiation shielding or even placing the crew in a form of induced hibernation are intriguing but still theoretical. The physical well-being of the travelers and the durability of their spacecraft becomes a major obstacle to overcome. And that is not all. Life support systems for such an extended journey represent another massive challenge. Unlike trips to the Moon or even Mars, where food, water, and oxygen can be carefully rationed for a relatively short mission, crossing the solar system would require entirely self-sustaining environments. Recycling systems would need to operate at near-perfect efficiency for potentially hundreds or thousands of years, and any failure could spell disaster. We are only just beginning to develop closed-loop life support systems on experimental missions, and scaling this up to support generations of humans is an extraordinary leap we have yet to take. Finally, the sheer amount of resources and energy required to even attempt such a mission is staggering. Building spacecraft capable of these feats would demand advancements not only in engineering but also in the way we generate and store energy. Current methods would fall woefully short for powering a spacecraft over such incomprehensible distances. From harvesting solar power far beyond the asteroid belt to possibly harnessing nuclear or even fusion energy, the technological demands are immense. In light of these challenges, it is clear that crossing the solar system is not simply a matter of scaling up what we already know. It would require a revolution in our understanding of physics, engineering, and human endurance. Yet, history teaches us that the greatest achievements often begin as what seem like insurmountable obstacles. This is the first step in a journey that tests not only our technologies but also our resilience and determination as a species. With these challenges in mind, the next step is to explore how future breakthroughs in propulsion technology could bring this seemingly impossible goal a little closer to reality. Moving forward, let us delve into the realm of futuristic propulsion technologies that could redefine how humanity travels across the cosmos. One promising concept is advanced ion propulsion. Unlike traditional chemical rockets, ion propulsion relies on electrically charged particles to generate thrust. Although the force produced is minimal, it can be sustained over long periods, allowing spacecraft to gradually reach astonishing speeds. This technology is already being used in some space missions, but significant advancements would be needed before it can support a journey across the entire solar system. Next, nuclear propulsion emerges as a potential game-changer. By utilizing the energy released from nuclear reactions, either through fission or fusion, spacecraft could achieve far greater speeds than current methods allow. Concepts like nuclear thermal propulsion involve heating a propellant, such as hydrogen, using a nuclear reactor to generate powerful thrust. Another idea, nuclear fusion propulsion, mimics the process that powers the sun by fusing atomic nuclei to release immense amounts of energy. Although this technology is in the early stages of development, it holds the potential to revolutionize long-distance space travel by drastically reducing travel times. And then there are the speculative technologies that feel as though they are pulled straight from the pages of science fiction. Take antimatter propulsion, for example. Antimatter is the mirror opposite of normal matter, and when the two meet, they annihilate each other, releasing tremendous energy. If harnessed effectively, even a small amount of antimatter could propel a spacecraft at unprecedented speeds. However, this idea currently faces insurmountable challenges, including the production, storage, and cost of antimatter, making it more of a distant dream than an immediate reality. Finally, we venture into the truly speculative with concepts like warp drives. This idea, rooted in Einstein's theory of relativity, suggests that space itself could be warped or contracted around a spacecraft, allowing it to travel vast distances without breaking the universal speed limit of light. Although captivating and explored in theoretical physics, warp drives remain purely hypothetical, with no practical framework currently in place to achieve such a feat. These futuristic propulsion technologies represent bold steps toward addressing the immense challenges of traversing the solar system. While many of these concepts are in their infancy, ongoing research and experiments continue to push the boundaries of what we think is possible. With each small breakthrough, we move closer to transforming these extraordinary ideas into practical tools for exploration. But propulsion is only one part of the puzzle. As we look further ahead, what role could generational starships and artificial intelligence play in overcoming the incredible distances of space? Let us turn our attention to this next fascinating frontier. Now turning to the concept of generational starships, let us imagine a spacecraft so vast and self-sustaining that it could carry generations of humans on a journey through the cosmos. Unlike missions we know today, where explorers return within years or even months, these starships would serve as homes for entire lifetimes, possibly spanning hundreds or even thousands of years. People would be born, live, and pass away, all while the ship continues its voyage toward a distant destination. Life aboard such a vessel would require an entirely new way of living. Cultures, traditions, and even human biology might evolve over time in response to the unique environment of deep space. Imagine the psychological demands of living in an enclosed habitat with no immediate escape and only the stars beyond the ship's walls for scenery. The mental resilience of the crew and the sense of purpose passed from one generation to the next would be as critical as the technology itself. Advanced artificial intelligence would undoubtedly become the cornerstone of managing such a complex system. From regulating life support systems to monitoring food and water supplies, artificial intelligence would act as the ship's caretaker, ensuring the survival of its human passengers. Beyond basic management, artificial intelligence could also play a pivotal role in making decisions that humans might struggle with across such long timescales. For instance, adjusting the ship's course to avoid unforeseen cosmic hazards or even mediating conflicts among the crew could fall under the domain of these advanced systems. Imagine a future where artificial intelligence evolves alongside humanity, not only as a tool but as an entity capable of understanding and adapting to human needs over the course of generations. Science fiction has long explored such ideas, painting vivid images of generational starships and their journeys. Stories like those in novels and films often depict not just the technical marvel of such ships, but also the profound cultural and ethical questions they raise. What happens when people are born into a mission they never chose? How might relationships, governance, or even the idea of family change when Earth becomes a distant memory and the ship becomes the only world they know? These speculative visions urge us to think deeply about the human spirit and its ability to adapt to unimaginable circumstances. While generational starships remain within the realm of speculative science, every step forward in artificial intelligence and sustainable technology brings us closer to making such ideas conceivable. Just as propulsion challenges demand innovation, so too does the question of maintaining human life and culture over such extraordinary distances. As we continue to expand our technological capabilities, another question arises. What would life truly be like if we succeeded in crossing the solar system and ventured far beyond it? Let us now explore this compelling possibility. As the next phase of the journey unfolds, let us imagine what life might be like beyond the boundaries of our solar system. Picture humanity venturing into the uncharted vastness of space, establishing new routines on spacecraft or even on distant planetary outposts. Daily life aboard these spacecraft might center around a blend of advanced technology and human necessity. People could live in highly efficient, self-sustaining environments where every resource, from air to water, is carefully recycled. Imagine homes equipped with advanced systems to simulate Earth-like conditions, artificial gravity, controlled climates, and even virtual reality recreations of terrestrial landscapes to maintain mental well-being. Education, work, and recreation would adapt to the unique demands of life in space, with new roles and responsibilities emerging to support the crew's survival and mission objectives. On planetary bases, the focus might shift to adapting to alien environments. Settlers would need to harness local resources, perhaps extracting water from ice or generating oxygen from the atmosphere to create habitable living conditions. Over time, these outposts could transform into thriving colonies, complete with their own ecosystems, agriculture, and infrastructure. The challenges of such a life would shape new cultures, traditions, and social structures, deeply influenced by the need to cooperate in these isolated, extreme settings. Imagine children growing up on a distant exoplanet, their understanding of home shaped not by Earth but by a landscape of alien skies and unfamiliar terrain. The notion of encountering other star systems adds another layer of intrigue. Each star could hold its own mysteries, planets with potential for life, environments wildly different from anything we know, and resources that could redefine how we live and explore. And then there is the tantalizing question of alien civilizations. What if, out there in the infinite cosmos, we were to meet intelligent beings? Such an event would challenge every aspect of human understanding, from our scientific knowledge to our philosophical beliefs. How would we communicate? What form might their technology or society take? And most importantly, how would such a meeting redefine our place in the universe? This drive to explore stems from something deeply embedded in us, the desire to expand our horizons and seek the unknown. Whether through robotic explorers or by humans venturing into the stars, the prospect of crossing the solar system and venturing far beyond represents a continuation of the journey that began with our earliest ancestors looking to the horizon. Even as we speculate about life beyond the solar system, it is clear that the act of exploration itself is not just about discovery, it is about defining who we are as a species. If we truly succeed in stepping into this new frontier, the experience will not only reshape our technology and lifestyles, but also challenge our understanding of what it means to be human. As we bring this cosmic journey to a close, let us take a moment to reflect on the staggering enormity of our solar system. From the blazing heart of the Sun to the icy edges of the Oort Cloud, the distances we are talking about boggle the mind. It is a realm so vast that even the fastest spacecraft we have ever built would require thousands of years to traverse its farthest reaches. Yet, as daunting as these distances are, they have not deterred humanity's drive to explore and innovate. The challenges of crossing the solar system, whether technological, physical, or even societal, are immense. Inventing propulsion systems capable of such journeys, building life support systems that can endure for generations, and overcoming the inherent dangers of deep space are feats that will demand nothing less than the full extent of our ingenuity and determination. But space exploration has never been just about technology or scientific milestones. It has always reflected something much deeper, a quest to understand our place in the vast expanse of the universe. As we dream of crossing the solar system someday, we are not just imagining spacecraft flying across unfathomable distances. We are envisioning a bold redefinition of what it means to be human. To stretch beyond the confines of our home world, to embrace the unknown, and to adapt to challenges we cannot yet fully comprehend. This is the spirit of exploration that has driven us from the very beginning of history. So, as we ponder this ultimate question, what does it truly mean to cross the solar system? Is it simply about the technology needed to get us there? Or is it about reshaping ourselves, our societies, and our very understanding of what it means to exist? The answers will come in time, through both discovery and reflection. What remains certain is that the future of space exploration will be as breathtaking as it is transformative. And perhaps one day we will look back at these early days as the beginning of a journey that redefined humanity's destiny. Thank you for joining us on this voyage through the mysteries of our solar system and far beyond. If this has left you inspired or curious, let us know your thoughts in the comments below. What excites you most about the future of space exploration? Do not forget to like, share, and subscribe for more incredible content as we continue to explore the universe together. And as always, keep looking up, the stars are waiting.